So far, guys, we've done algebra proofs where you solve an algebraic equation and justify your steps for that. Last class, you were doing segment proofs where, again, you're proving parts of segments where either midpoints are equal to each other, things like that. Last part of proofs we're doing is angle proofs. And just like every other proof, we always have a given, and it's right there. And notice it's the first one. So we're going to go ahead and fill in our given. And then the trick I have told people is if in the statement, so on the left side, if you ever see like verbiage, for example, it says is a right angle, and then the next thing is 90 degrees. In this case, it's always in this case going to be definition of right angle. And I'm going to abbreviate def of right angle. That's my trick to you, is if you do see words in the previous statement, usually the following reason will be the definition of those words. Okay, next thing they're saying is angle PQS, so I'll trace it out, PQS plus angle SQR, makes PQR, which makes PQR. So remember, this is a small plus a small equals a big, so that would be, in this case, angle addition postulate. I'm going to abbreviate. I can't fit postulate, so I'm just going to put post. Okay, next, we took out PQR, and we put in 90 degrees. So remember, when we take something out and put something in, we are substituting. And again, we have words, right? They're saying PQS plus SQR equals 90, and then they're saying they are complementary. So again, this would then be just definition of complementary angles. And due to space, I am going to be abbreviating. Remember that symbol right here means angle. If you don't remember that, please write that down. If you need to pause here, pause here. I'm going to move on to the next proof. Okay, so in this proof, notice we have a semicolon. So in this case, I have, looks like two givens. I have 2 is congruent to 3, and 1 and 2 are a linear pair. So I'm going to find those in the proof and already write given. So that's number 1 for sure. And it also looks like that is line 3. That's what I always do. I always look at how many givens I have and find where they are and fill those in. And I am 2 steps closer to finishing this proof. Okay, so then going back from 1 to 2, we're going to backtrack now. From 1 to 2, the only thing that I noticed change is that I had a congruent sign and now I have an equal sign. And so when I change out those symbols, I'm always exercising the definition of congruence. Okay, then we have a given. Then we go from 1 and 2 form a linear pair to 1 and 2 are supplementary. So if I'm going from 3 to 4, I'm exercising the definition of linear pair. Then from 4 to 5, I go from saying they are supplementary to that they add to 180. Again, I have the words. So now I'm having definition of supplementary. Okay, I had to fit that in there. Okay, from 5 to 6, you noticed measure of angle 1 stayed measure of angle 1. That's the same. 180, 180, that stayed the same. The change happens here where we had measure of angle 2, but now we have measure of angle 3. But in step 2, I know they are the same thing. So when I take something out and put something that's the same in its place, that's always substitution. Okay, I'm going to erase all my markups so we can see the proof. And lastly, so if 1 and 3 add to make 180, that means they are supplementary. Again, I see a word, so I'm going to use the definition of supplementary as my reasoning. I can't fit my Y. Y. Okay. Pause here if you need to keep writing. If not, I'm going to move on to proof number 3. Okay. Proof number 3, again, I see a semicolon, so my guess is my givens are getting separated, so I want to find them. 1 and 2 form a right angle, 1 and 2 form a right angle. That's number 1. Second given is 1 plus 3 equals 90, and that looks like is in line 3 there, so that is also a given. Okay, 2 out of 5, I'm in a good spot. So then I am going from 1 to 2. They're saying they're right, that 1 and 2 are a right angle, so 1 and 2 are complementary, and that would be the complement theorem. Okay, we have line 3, that's a given, so from going 3 to 4, if angles 1 and 3 add to make 90, that means they are complementary. Then I see the word, so it's the definition of that word. Oh no, I'm running out of space. There's a Y at the end of that. Okay, and lastly, that means 2 and 3 have to be congruent. This would be the congruent complement theorem. I can't fit it. Anyways, that should be theorem. And the reason we're using the theorem here is because angles 2 and angles 3 are complementary to the same angle. So that's why I would use that there. Let me know if you have any questions. Pause here if you need to. We're going to move on to the next 3 proofs, which I'm going to half fill out for you. You're going to have to fill out the rest, and I will come and check them for you. Okay, in angle 4, I will give you number 3, which is a given. And I will give you number 4, which is definition of bisector. Remember, a bisector is something that cuts something in 2 equal or congruent parts. Don't forget that. Pause here if you need to. In proof 5, let's do, I'll do number 3, which is angle addition postulate. I'm going to abbreviate. Let's do number 5, which is substitution. And let's do number 7, which is definition of congruence. Okay. Pause here if you need to. I'm going to move on to the last proof. Okay, last proof. This one has a lot more happening. So let's do one of the givens. Let's do definition of complementary angles for number 4. I'm using abbreviations, so please let me know if you need help understanding my abbreviations. I think I'm just going to do all the evens for you guys. So then definition of congruence for 6. Eight is substitution. And lastly, 10 is definition of congruence again. Okay. This will be the end of the video. Call me over to check your proofs to make sure you're getting this, and let me know if you have any questions.